And now I would like to ask to introduce the next school, which is the Prototype Experimental School of the University of Patras, to take the floor, the presenting group.
Greetings, ladies and gentlemen, fellow students and distinguished guests. My name is Tatiana Gudis, and on behalf of my 19 classmates that worked on this project, with the support and guidance of our teachers and professors, we represent the Model Experimental High School of the University of Patras. After conducting thorough research concerning various aspects of nanotechnology, we came up with a highly efficient electrical energy-producing nanostructure. At this point, I'd like to thank for our research Professor Mourzis with his inspiring presentation at our school and his invitation to the Department of Mechanical Engineering and Aeronautics and his interesting presentation with his students that worked on the project of Formula Student. Moving on. This is the table of contents of our presentation. We would like to thank all the other schools for their great presentations. We aim at a presentation as captivating as all the previous ones. So, throughout history, it has been proven that the greatest ideas are a result of careful and close observation of reality. It is the world that surrounds us, our everyday life, that inspires us and gives us motivation to seek for something new, something better. So let's look around us. Let's take a close look at reality today. What do we see? We see an economic crisis that has lowered the quality of living all around the world. In addition to this recession, we are facing a rapid population growth, and to top it all, energy reserves are becoming less day by day. Well, that doesn't sound that bright, does it? Being students, we also made an attempt to focus our attention to reality in schools. Well, things there are not that much better. Needless to say that central heating, especially in our country, is minimum in our schools. Of course, there is no air conditioning, making the last months of school intolerable due to the high temperature. In fact, funds dedicated to education are considered unnecessary and not so important the time being. So we asked ourselves, how can the science of nanotechnology help in order to face all these vital issues? So with that question on our minds, we came up with our proposal. What do we propose exactly? Well, it's very simple. It's nothing more than a nanostructure that gives us the opportunity to take advantage of the constant movement and sound produced daily in our schools and in any area of mass concentration for that matter, during lessons or breaks in the gym or in the corridors in order to generate the energy needed for its daily function. So you might wonder why we chose this specific idea to present here, why this idea is so special and so innovative in our opinion. Well, frankly, because it is one step closer to what we consider ideal for our school, for any school for that matter, and what answers all our questions and satisfies our needs that have aroused these past few years. Well, we are talking about a school that runs exclusively on alternative and environmentally friendly energy resources, a school that doesn't only thrive in terms of education but flourishes financially, a self-sufficient school with economic heating, lighting, and air conditioning, and finally a school that is not fossil fuel dependent. Well, okay, in theory, of course, everything seems idyllic, ideal, and feasible, but how exactly does this proposal that we have work? How does it function? Its function is based on three basic natural phenomena. The photovoltaic effect. The general term photovoltaic refers to the industrial lining of more than one photovoltaic cells. The piezoelectric effect which is a term that's described in the property of certain materials to produce electrical voltage as a result of applying certain mechanic pressure or oscillation. And last, superconductivity, that refers to the state which a material has zero ohmic resistance. At this point, I'll give the stand to my fellow student who will walk you through the exact way this proposition functions. Thank you very much for your attention.
This nanostructure is categorized as an energy converter, also fulfilling the requested needs for transportation of the energy. It's designed to convert mechanical and solar energy into electrical energy using the piezoelectrical and photovoltaic phenomenon. Right after the conversion, it's capable of transporting this amount of electrical energy and delivering it to its destination with near zero losses. The structure of this nanosystem mainly consists of two different parts viewed as different layers of materials: the mechanical to electrical energy conversion part and the solar to electrical energy conversion part. The energy transportation part is built within the photovoltaic system, so there is no need to be considered as a separate part of the nanosystem. The shape of the nanosystem is a hexagonal prism. This particular shape offers great mechanical properties, a high degree of strength, and also leaves no empty space if the units are placed side by side. 6 units are attached to each particular unit. The first part of the nanosystem, the photovoltaic and energy transportation system, is located on the surface layer of the nanostructure and consists of a superconducting photovoltaic polymer. This material is designed not only to convert the solar energy into electrical power, but also to transport it with minimal resistance. By the time that solar rays are absorbed by this material, electric current starts passing through the superconductor, being transported to the full length of the surface of the superconductor, of the nanostructure, and to other similar nanounits as well, as they're in contact, as mentioned before. Needless to mention, the superconductor presents a high critical temperature and does not need to be hypercooled in order to gain its superconducting properties. Also, standard methods of photovoltaic cell manufacturing are followed so that we are able to create the necessary PN junction by mixing small amounts of other materials with the main photovoltaic material. The second part lies deeper within the main and most important, within the second layer, and consists of the main and most important part of the nanosystem, its core. Here, the material used is a piezoelectric crystal-type material and plays the role of a filling, as it fills up the empty space inside the nanostructure. In order to produce electrical power, the piezoelectric material needs to receive waves of mechanical energy. Consequently, when a wave of this type hits the surface of the nanostructure, it travels through the first layer until reaching the piezoelectrical filling. When it reaches it, the wave's mechanical energy converts into electrical power, which is transported to the surface where the superconductor takes care of the efficient delivery of the energy. After the electrical energy production, the produced power can be used instantly, stored, or transferred directly to the general power network. Before exiting the production process, all nanostructures are being subdued for the main upgrade. The main upgrade is the process where the majority of produced units will be enriched with a number of substances that will protect the nanosystem from environmental factors, such as water, UV rays, toxic agents, and so on. It's considered as a basic process, and it's strongly recommended for every user of the nanosystem. The main upgrade will also prevent any unwanted process from taking place, and at the same time it will protect the environment and the human society. The main upgrade is executed by the manufacturer and industrial producer of the nanosystem. The main upgrade is the final stage of the industrial process, and after its completion, the nanostructure will be available as a coating powder, as a textile, or inside the liquid solution. These are the default, standard, and absolutely basic options of the specific product. The nanostructure is designed so it can be improved by using specific add-on modules or chemical substances. These are great advantage, so we can develop different versions of the very same nanostructure so it can accomplish its different task every time under different conditions. So the possible applications of these nanosystems are practically infinite. These applications will now be presented by my fellow student, to whom I will the floor.
So, once we have explained in detail how this structure works, I will attempt to present you its possible applications. First of all, we should note that we turn to nanotechnology as it is undoubtedly the most promising scientific field when it comes to facing the huge issues raised by the world scientific community of today. Once again, it is important to clarify that our idea is based on a very simple logic. By applying mechanical pressure on a surface which can absorb solar rays at the same time, we can be producing electrical energy literally out of nothing. As mentioned earlier, the current heating problems in our school community served only as an inspiration for us in order to design a nanostructure in such an innovative way so that it can fit theoretically everywhere, having thus countless applications, which prove that it's worth it for all of us to expand the research on this nanostructure. So, in what other fields can we apply our nanostructure? Firstly, as you can see, it can be applied in the aviation industry as a covering material on aircraft's wings, fuselage, and other external parts. In civil engineering, in this sector, the nanosystem will be used in order to preserve structural stability and strength against environmental factors in buildings, bridges, roads, or rail tracks. In shipbuilding, covering ships and submarines' external surfaces and other parts of the ship. In railways, in areas like external surfaces, internal surfaces, or other mechanical parts, generally where maximum mechanical pressure or solar rays are expected. Most of all, in electronics, the nanostructure can be used as a primary construction material, introducing the brand new idea of autonomous charging. The longer electronic devices will be used, the greater amount of electrical energy will be produced. In energy production facilities, the nanostructure can be used as a power preventive energy producer. Lastly, in the industry of clothing, the nanosystem, built in the clothing apparel in the form of textile, will be producing energy with every single move of the body. At this moment, my partner will analyze the conclusions of our research.
As mentioned earlier, I will now present you the conclusions of our paper. At first, the heating problems in our school community inspired us to design and produce our nano project. To build a nanostructure, we focused on the photovoltaic effect, the exploitation of the piezoelectric effect, and the superconductivity. It is believed that our achievement is accepted in the global community as an ultimate low-cost proposal for a greener and efficient electrical energy production. Not to mention that nanotechnology can offer opportunities in terms of the creation of new industries and financial improvement. Last but not least, the exploitation of nanotechnology through novel activity could have positive effects on the Greek economy. That was a brief description of our proposal. We made an effort to make our suggestion clear to you, teachers, students, and distinguished guests. Thank you all very much for your presence here with us and for the attention you have paid to our presentation.